Hello everyone, in this video we'll see about flip-flop conversions. There are many types of flip-flops available and they are SR flip-flop, JK flip-flop, D flip-flop and toggle flip-flop. And we can convert one type of flip-flop to the other using this 6 steps. So we'll see these steps with the help of an example. So our question is, we have to convert JK flip-flop to D flip-flop. So the first step is to identify the given flip-flop and the required flip-flop. So the given flip-flop is JK flip-flop here and the required flip-flop is D flip-flop. So that is the first step. Now we can move on to the next step, that is the second step. So that is to write the characteristic table of the required flip-flop. So here the required flip-flop is D flip-flop. So we have to write the characteristic table of D flip-flop. The characteristic table is, we will be writing Qn plus 1, that is the next state in terms of the present state and the input D. So we have written the characteristic table over here. So as you can see, when a clock pulse is applied, whatever data we are giving, whatever value we are giving at the input, D input, that will be transferred to the output. On the application of a clock pulse, whatever value we are giving at the D input, that will be transferred to the output. So when we give 0, then Qn plus 1 will be equal to 0. The next state will be equal to 0. Irrespective of the value of Qn, Qn plus 1 will be equal to 0. When we are giving 1, then Qn plus 1 will be equal to 1. Similarly, for the next two cases also, if we are giving 0, we will get 0 at the 0 as Qn plus 1, and if we are giving 1, we will get 1 as Qn plus 1. Now the third step is to write the excitation table of the given flip-flop. So the given flip-flop is JK flip-flop. So the third step is to write the excitation table of JK flip-flop. So excitation tables will be writing the present state and next state, and will be writing the input conditions, that is J and K, corresponding to the present state and next state. So there are 4 combinations, 0, 0, 0, 1, 1, 0, 1, 1. And we have seen the excitation table earlier. So that is corresponding to 0, 0, JK will be 0, don't care. And 0, 1, 1, don't care 1, don't care 0. So an easy way of remembering is to, if we move from top to bottom of this column of J, we can see it is 0, 1, don't care. And if we move from bottom to top, then we can see it is also 0, 1, don't care. So that is the excitation table of JK flip-flop. Now the fourth step is to combine the above characteristic table and excitation table to form the conversion table. So now we have to draw the conversion table by combining the characteristic table and excitation table. So we can draw the conversion table over here. So that is Q1, D, Qn plus 1, J and K. We have combined these two. So we can write and for Qn 0, Qn plus 1 0, JK is 0, don't care, 1, don't care 1 and don't care 0. Now the fifth step, that is using K-map, simplify the logic expression for excitation inputs of the given flip-flop. So the given flip-flop is JK flip-flop. So now by using K-map, we have to obtain the simplified logic expression for J and K. So we can draw the K-map for J. So there are 4 combinations of inputs, Qn and D. So this is 0, 1, 0, 1. So corresponding to 0, 0, J is 0, 0, 1, J is 1, 1, 0, it is don't care, and 1, 1, it is don't care. So now we can do the grouping. So we can group the 1 like this. So we will get, this is the K map for J. So we will get, this is equal to D. So we will get J as D. This is Qn bar and this is Qn. So it gets cancelled and now J will be equal to D. Now we can draw the K map for K. So this is Qn and this is D, 0, 1, 0, 1. So corresponding to 0, 0, K is don't care. corresponding to 0 1 K is don't care, 1 0 K is 1 and 1 1 K is 0. Now we can do the grouping like this. So this is D bar, this is D and this is Qn bar and Qn. So we'll get K as, this is the K map for K. So we'll get K as D bar. So this is the fifth step. So we have drawn the K maps and find the expressions for J and K. Now the sixth step is to draw the circuit of the desired flip-flop. That is, we have to draw the circuit of D flip-flop using the flip-flop conversion logic. That is, we have got the flip-flop conversion logic now. That is, J is equal to D and K is equal to D bar. So using that conversion logic and the given flip-flop, that is the JK flip-flop, we have to draw the D flip-flop. So we'll be drawing D flip-flop using this conversion logic and the given flip-flop, which is the JK flip-flop. So we can do that. So now we can draw the JK flip-flop. We have to convert JK flip-flop to D flip-flop. So we have drawn JK flip-flop and the outputs are Q and say Q bar. Now we have got J equal to D and K equal to D bar. This is the conversion logic. So we can give D input directly to J and it can be inverted and given to K, so that K becomes equal to D bar. So this is the required flip-flop or the D flip-flop using the JK flip-flop. So D flip-flop is obtained from JK flip-flop by giving data input directly to J and inverting and giving it to K, and this is the clock pulse and the outputs are Q and Q bar.